Good morning, everyone, or good afternoon, or perhaps evening, wherever you are in the world. My name is Lance McCall, the Global Campaign Manager for GenBand, and I'd like to welcome all of you to our webinar today on enhanced voice services. I'm glad all of you could join us. Before we get started, I do have just a couple housekeeping items to go over. This webinar is a GoToWebinar webcast webinar, so it may look a little different than you're used to. But audio by default is using your computer or your device's audio, and that is the only option for the webinar today. We do have a chat feature, so periodically during the webinar we will be sending you some messages. You might see a notification icon by the chat bubble, so you can click that to see those messages. Also during the webinar we do encourage you to ask questions, so down at the bottom you can type your questions right there and submit those. We do have someone standing by to answer those questions, and so please do take advantage of that. Moving on to the next slide, we also have a PDF or a document icon there. So we have several downloads for you today, so click that icon to access those documents, and you can download there during the presentation today. Also, we'll have two surveys or two poll questions, so whenever we're ready for those poll questions, they'll pop up on your screen much like you see there, and we'll walk you through those. So that's really all there is for housekeeping. I'd like to go ahead now and introduce our presenters today. We have Greg Collins, founder and principal analyst for Exact Ventures. We also have Sanjay Bhatia, Vice President of Solutions Marketing and Strategy for GenBand. So really happy to have both of them with us today. So that's really all I have, and I'm going to go ahead and pass things off to Sanjay. So Sanjay, if you give me just a moment, you should have control now of the slides.
Welcome to the webinar. We've got a great webinar planned for you today, and we're going to take you through that. So let's quickly, let me give you an overview of what we're going to get into. Greg, who's a great analyst, has a great view of the market dynamics around voice over LTE and high definition voice as well as NFV. So he's going to go through that to begin the webinar, and then I'll take you through the Enhanced Voice Services Codec and what advantages it provides the service provider as well as the end user. And then we'll start getting into how EVS can be implemented in mobile networks moving forward. So we've got an exciting agenda planned here, and so let's go ahead and get started. Let's see here. Okay. So, Greg, I'll hand it over to you to go through the market dynamics.
Sounds great. Thank you very much, Sanjay. And hello, everyone. I'm going to try to advance the slides here. If that's, I guess, trying to, Lance, maybe you can help me advance the slide. Oh, there it is. Sorry. Thank you. So I'd like to, again, talk about the market progress for voice over LTE. And with all of the noise or hype around data and video over wireless connections, voice remains a foundational technology for mobile operators. So obviously, if you have poor voice service, people are very unhappy, and it's a prime candidate for churn. And at the same time, excellent voice service can really cement loyalty for operators. And voice over LTE has some inherent advantages over OTT voice. Not only will it have dedicated bearers through the radio and through the core network, which can assure the quality of service, there are also HD codecs. And with HD codecs, the voice calls to your family and to conference calls are that much richer, and you can really feel the difference. It's a visceral difference, the quality of the voice with HD voice, and that will very much, I think, help to cement loyalty and enable mobile operators to recapture or start to capture more of the communications, especially when a lot of users are initiating voice calls outside of the native dialer. So with that, I'm going to go to the next slide and look at just the progress so far with VoLTE subscriptions. So today we're at about 500 million worldwide, and with increasing penetration in North America and in some of the developing regions, we have the market going to about $3 billion in, not 3 billion, 3 billion subscriptions in 2020. So we're just at the very early days of the transition to VoLTE. Now with the next slide, talk about, so just to give that a little context, so on this slide, the area represents the number of subscribers, and the line represents the penetration or the percentage of VoLTE that is the total voice subscribers. So you can see even in 2022, still there's about a third of subscribers are VoLTE, with the remaining 2/3 being 2G, 3G voice. So we'll have many years of investment in this transition from 2G, 3G circuit voice to voice over IP. And then lastly, I will go and talk about this transitional shift to NFV and cloud. So not only is the voice market transitioning to VoLTE, underneath that is a big transition to cloud and to virtualization. And you can see some of the forecast figures that I have on the slide. Right now, the market's dominated by physical, but increasingly vendors are and operators are deploying virtual IMS, virtual VoLTE, and that is a really big area of investment, excuse me, for mobile operators, going from physical to virtual to cloud. And I guess with that, I will turn it back over to Sanjay. Thanks.
Thank you so much, Greg. So, so as you can see, really VoLTE growth continuing, as well as the importance of high definition voice and the growth of NFV. So next slide. Let's see. Okay, so what I'm going to do next is talk about the Enhanced Voice Services Codec. So what is the Enhanced Voice Services Codec? What EVS, in short, it stands for Enhanced Voice Services, and it is a high fidelity codec used for mobile networks. It was introduced by 3GPP in release 12 about 1.5 to 2 years ago, and officially became part of the standards. This is the codec of the future. It is pretty much allows for a full range of audio hearing capabilities from all the way from 50 hertz to 20 kilohertz, which is the full audible range of a human ear. Typically, the range between 14 kilohertz and 20 is for high definition music as well, right? So the beauty of the EVS codec is that it supports music quality and allows mixing of voice and music for content. So it's bringing in high fidelity for voice and music. It's also giving you high call reliability, and it allows you to maintain high voice quality and audio quality in very harsh conditions. The third point, and this is very important, is it provides for better network efficiencies on the link side of the equation, allowing better voice capacity and throughput on the up and down links for voice. This provides some relief to service providers on the network efficiency side of the equation. And then beyond that, it also, provides improved coverage and better voice qualities under packet loss and transmission errors. With wideband AMR, but it does lose some of the advantages if you run EVS in the wideband AMR backwards compatible mode, and I'll get into that a little bit further down in the presentation. So clearly, you can see the importance of the enhanced voice services codec and its ability to, go well beyond the wideband spectrum from 0 to 7 kilohertz and go into super wideband and full band all the way to 20 kilohertz as a bandwidth. So what are some of the bit rates supported with the EVS codec in the primary mode? It ranges based on whether you're doing wideband or super wideband. You can see super wideband begins at 9.6 kilobits per second and upwards, and ranging all the way up to 128 kilobits per second. So you can clearly see that you're going to get a higher voice quality and a more natural voice as you go from wideband to super wideband to full band. And it also, there is a support for what's called a channel aware mode for 13.2 kilobits per second, which provides even better error resiliency and concealment, and that again improves voice quality and the ability to fully engage in conversations and improve the end user experience. So very, very important aspects and pluses way beyond wideband AMR that is deployed in many networks today with voice over LTE for those that have deployed voice over LTE. So that is kind of the full range of bit rates supported by EVS. So now, if you look at today's codecs in terms of AMR and wideband AMR, say you're looking at AMR at 12.2 and wideband AMR at 12.65 kilobits per second, you have the opportunity to improve the voice quality and the voice capacity in your LTE networks by utilizing the EVS codec either at 13.2 or less than 13.2. So say you have the option of deploying EVS at 9.6 or at 13.2 with channel aware mode, and it'll give you automatically both a better voice experience for your end subscribers, as well as give you relief on your link capacity. So very, very powerful concept. So you can actually increase voice capacity with the same or improved voice quality as wideband AMR, or improve the voice quality with the same capacity, right? So lots of options available to you to enhance the end user experience as well as impact the capacities in your network. Given all these advantages, there are a number of service providers that have already begun to deploy EVS with their VoLTE networks, right? T-Mobile in the US was one of the first ones to launch. They have already launched EVS, and there's a great blog out there from their CTO that is online that you can go read that highlights all the benefits that EVS is providing T-Mobile in their network. NTT Docomo and Vodafone in Germany have also deployed EVS as part of their network. So these are some of the early networks that have begun deploying EVS as part of their VoLTE networks. And you can also see a number of smartphones providing support for the EVS codec in the different modes. So you can sense the importance of EVS, and it's kind of qualified here with a number of these operators realizing the benefits and beginning the implementations of EVS with VoLTE. So with that, let me, Lance, if we can get a quick survey done on this. Lance, I'll hand it over to you.
Thanks, Sanjay. Yeah, so that survey should be up on your screen at the moment. What are your plans for deploying Voice over LTE? You have three options there: already deployed, or currently deploying, planning to deploy, or currently we don't have any plans. So if you would just take a minute, make your selection there. And Sanjay, if you can look over on the right side, I'm sure you can see those results coming in. Looks like a lot of you have already voted. We will just take another second or two to let a few more of those come in. And we can actually share these results with the audience.
Excellent. Yeah, why don't we share the results? What all of you are saying is about 40% of you in your service provider networks you've already deployed or currently deploying Voice over LTE. 20% are planning to deploy, and then about 40% have no plans currently. So that's kind of interesting. The 40% of you have already got VoLTE in place or are putting it in place, right? And then the other 20% are planning. So good 60% of you in the audience have plans or have deployed Voice over LTE. So that's kind of interesting and pretty much what I would have expected. And given what Greg said earlier about what's happening in the market. So why don't we go to the next poll question? This is another short one.
Yeah, thanks, Sanjay. And thank you all for answering that first question. The second one here, what are your plans for deploying the enhanced voice services, the EVS codec? Same options as the previous question. We've already deployed, or we are currently deploying. We haven't yet, but we're planning to do so. Or the last option, we currently have no plans. Again, seeing some results come in, we'll hang tight just for a second or two to let more of those come in. So it looks like we have about 30% have voted at this point. We'll give it another 10 seconds or so.
Yeah, sounds good.
Yeah. Okay, Sanjay, I'm going to go ahead and close that poll out, and we'll share those results with the audience as well.
Okay, excellent. Okay, so this is very interesting and pretty much, again, given it's early days for EVS, it's very interesting to note about 8% have already deployed or are currently deploying, and it's very interesting to learn that about 33% of you are planning to deploy enhanced voice services codecs. Okay. And then about 58% no plans currently, and hopefully once you've seen the advantages that EVS can provide in this webinar, convince you to move forward with that. But that's great. Thanks for taking the survey. Gives us validation of some of the things we started off with. So with that, let me go over to the next part of our webinar. Lance, you want to forward the slide? Excellent, thank you. So media interworking and transcoding in VoLTE network. So if you're going to introduce EVS in your VoLTE networks, you have to think about how you're going to manage the media interworking and media processing and transcoding of the EVS codec with respect to other codecs that are widely utilized in mobile networks as well as interconnect networks and fixed networks. So let me just step back here and kind of show different networks and when they're interconnected together and within those networks, there's different points in those networks that typically have transcoding occurring, right? Both in the core and the edge of those networks. So if you look at mobile networks, typically you would do transcoding both in the core of the network or at the edge of the network. Now, with 3G and wideband AMR, you had transcoder-free operations for obvious reason. And as you will see with EVS, I'm going to explain to you why it would make sense to actually do some transcoding to gain the full benefits of EVS. So anyway, you can see here the transcoding points in interconnect and IPX networks as well as fixed networks. And you would need media interworking as part of those transcoding points as well. So with that, let's look at specifically for 4G voice over LTE environments, right? So if you have, say you're introducing EVS on certain mobiles and certain subscribers begin having EVS, you're likely going to have to do some transcoding to gain the full benefits of EVS in the core and the edge of the network. So you're seeing some of the IMS functions that are involved in doing that transcoding in terms of an MRF or an IBCF at the edge, and also for TDM interconnects, MGCFs and MGWs get into the picture as well. So again, this is more specific to VoLTE networks and the transcoding points there. So let's now talk about what happens when you want to introduce EVS and want to gain the full advantages of EVS, things that we talked about in terms of superior voice quality, the capability to handle errors and resiliency against errors, a better network efficiency, and giving you advantages on network capacity as well on the links. You need to look at, so say you start introducing EVS in your networks, typically the number of mobile-to-mobile calls in a typical network is less than 20%. It may be as low as 10% as well. So once you start introducing EVS in your networks, initially you're going to have very few subscribers with EVS capabilities, and as more and more subscribers begin to get EVS, that number is going to grow. But typically, the advantages you're going to get from introduction of EVS from a mobile-to-mobile perspective in your network itself is going to be limited to a max of 20%, depending on what percent of your calls are staying within your network or going to other networks outside, to the PLMN as well as the PSTN, or going to other parts of your network that are just purely AMR or wideband AMR. So it's important to take all these factors into consideration, and what you're going to see is when you start transcoding in the network, you start getting the benefits, and you'll be able to expand the benefits to a broader range. And that's what I'm going to show here in this next chart, that the blue line kind of shows the maximum benefits you may be able to get without transcoding for the mobile-to-mobile calls within your network. And you say they're going from EVS to EVS. But once you introduce transcoding in the network, your benefits start increasing substantially, because on that single leg that is involved with EVS, you immediately start getting the benefits of the improved voice quality, as well as the spectral efficiencies that EVS provides. So all of a sudden now, you can actually benefit from EVS in a much broader, larger way by introducing transcoding between EVS and either AMR or wideband EMR, depending on what you're interconnecting to. So that's a very important point to understand. Okay. So now, given that you would need to introduce media interworking and transcoding in your network to take the full advantages of EVS, what are some of the best options and best practices for introducing that media processing? Given the EVS codec requires quite complex processing and scale. Its NFV implementation provides a whole bunch of advantages. So let's first start with why are service providers such as yourselves thinking about utilizing NFV for virtual IMS functions? So here's some data from an analyst firm, IHS, in highlighting why some of you have been thinking about implementing NFV for different virtual IMS functions. Things like the ability to scale services up and down very quickly, operational efficiency, all the things that NFV is going to provide you in terms of agility, OPEX and CAPEX savings, and the ability to automate a lot of your network functions. So these are some of the broader reasons for implementing network functions in the context of NFV. So let's look at, and here again, just highlighting some of the benefits of NFV, right? The ability to geo-distribute functions as well. Very important if you want to be able to do things for mobile edge computing and be able to deploy VNFs on the edge very quickly from a centralized data center, or using powerful VNF managers and MANO capabilities. So here's an example of us utilizing our own VNF manager to distribute and bring up VNFs very quickly in an automatic and elastic manner. And this one is highlighting the advantages of efficiencies and resource efficiencies that you gain in the data center by performing dynamic scaling and elasticity of those VNFs in your core and edge data centers. So let's get to now, why would you want to use NFV for EVS transcoding, and why does that make sense? And this is an extremely important point. So the reason you want to implement transcoding for EVS using NFV is that there are certain limitations based on hardware DSP or appliance-specific implementations that are prevalent in the networks today and have been. Those have been fine-tuned over the whole number of years, but as you know, every new wideband codec requires more and more processing capacity, And using dedicated appliances is going to limit you on the capacities you can get per appliance, and make it a very costly and total cost of ownership limiting proposition to be able to deploy codecs such as EVS at broad scale within your networks. And so it becomes a natural proposition to look at NFV and the use of elasticity and automation and all the resource advantages that the NFV provides in the core and edge data centers. It really makes sense for utilizing NFV as a mechanism to deploy EVS. It gives you high scale, high density, a lower total cost of ownership. It gives you continued performance optimization. For instance, we're working very closely with the likes of Intel to ride the performance improvement curve, and not only stop at that, but also fine-tune and optimize our advanced media software VNF for doing so. So we've been able to achieve great results relative to appliance-based mechanisms, and that's what I'm going to show you next here is an example of implementation of VoLTE EVS using NFV. So what we have done is, as part of our transcoding and media interworking solutions, we have a number of VNFs, and we have a VNF manager that lifecycle manages those VNFs and automates them, as well as elastically scales them in your core and edge data centers. So we have a distributed architecture with different VNFs for separate VNFs for the signaling and control planes versus the user plane and media processing. So the media processing VNF is our advanced media software virtual network function, which is fully elastic. C3 is our elastic session control and routing engine. And then for security at the edge, for functions like IBCFs, we have the session border controller, advanced control software as well. And all managed, lifecycle managed with our VNF manager that's part of our Mano offering. And we work very closely with a whole number of ecosystem providers for the NFVI and the rest of the Mano within the NFV Etsy architecture. So this is kind of the solution that GenBand has utilized to benchmark and figure out the performance improvements of EVS-based transcoding with NFV. And what we have seen is we are getting at parity or better performance versus appliance-based approaches. In fact, we've got some great results that we have seen, and given our expertise on implementing transcoding in very, very large-scale networks. In fact, we have two large networks, tier 1 networks that have over 50 million subscribers. Those numbers are pretty big and have grown bigger as you speak. And we've deployed some of these solutions that I just talked about in those networks. And so what we have seen as part of our expertise in media software is we are seeing tremendous performance improvements when you utilize NFV and provide EVS transcoding based on NFV. You get tremendous advantages when you do that, and on top of that, you can take advantage of the performance improvements from the data center NFVI and compute resources from the likes of Intel that is always on top of the technology performance curves and introduces year-over-year performance also on the data center hardware. So clearly tremendous benefits in implementing NFV-based EVS transcoding. So let me now just slow down here and show you the kind of topologies and the additional capabilities and features that you can get with implementation of EVS on an NFV-based architecture. So what this chart is showing is it's showing our VNF manager that has instantiated and brought up several control plane VNFs. You can see those in the top of that picture for both the MRFC and an IBCF, for instance, for both core and edge transcoding. You can see those being on an OpenStack-based virtualization environment, and you can see those are cluster-based and are fully geo-redundant across different sites. And then what you see at the bottom is the media or the user plane processing at the edge of the networks with our advanced media software in edge data centers, again, fully redundant and in across different geo-redundant sites. So basically what we can enable is our multi-VNF and multi-cloud environments utilizing our VNF manager to be able to launch and elastically scale and lifecycle manage all these virtual network functions. And the beauty is we have some unique capability sets in terms of how we manage the media processing for a given set of subscribers in a certain specific set of geographies. And so we've got some unique capabilities for the solution associated with that as well to optimize, further optimize your performance within your networks. So this is kind of, this is what I was trying to highlight here is the benefits of implementing an NFV-based approach that can actually allow you to deploy NFV-based transcoding both in the core and the edge in a very geo-distributed and highly reliable mechanism at tremendous scale. And I gave you some examples of the type of scales we are used to with in-network approaches. And so there's no reason why the same level of scale cannot be applied into an NFV based approach. In fact, you may be able to get even larger scale deployments going given the whole fundamental premise behind NFV and cloud-based approaches within core and edge data centers. Okay, with that, I'll go on to the next slide. So that was kind of a quick summary of voice over LTE and introduction of EVS in VoLTE networks. Clearly, as Greg stated, you know, VoLTE deployments are in motion. The survey responses you provided clearly showed that, and the growth is continuing on VoLTE globally. EVS, as I stated, really provides you with great benefits in terms of providing a better user experience in terms of voice quality for your end customers, as well as providing you with spectral efficiencies and better error performance for your media processing. And deployments of EVS, as I highlighted, T-Mobile in the US and NTT Docomo and Vodafone in Germany have already begun with their EVS deployments, and we expect many more to come down the pike here. And the other key point was to be able to gain the full advantages of EVS, you need to transcode to really gain the full benefits of EVS in the core and the edge. And NFV-based approaches are the best suited mechanism for providing that EVS media interworking and transcoding based on our experience. And the GenBand has clearly, as I showed you, some very great market-leading solutions for NFV-based EVS transcoding. So with that, Lance, I'm going to hand it over back to you.
Thanks, Sanjay. Yeah, so we have a few documents here, as you can see on the screen, to download. You can click that option right there. You can also find those in the resources area of your interface. There should be a PDF icon. You can click there and download those. Also in the chat area of the interface, you should see a message about Mobile World Congress. So you can see here on this slide, we will be at Mobile World. So if you do have plans to be in Barcelona for that event, please come by our booth, visit us. You can see a lot of the things that Sanjay's been talking about today in action, live in person. So please do check that out. Now, I think we've had several questions come in through the chat. So first of all, thank you everyone for doing that and giving us your questions. Prasanna, do you have a few of those you'd like to address with the audience?
Sure. There are a couple of interesting questions, and I would like both Sanjay and Greg to answer these, which covers both the industry as well as some technical questions. So one question was, apart from support by mobiles and non-uniform coverage of VoLTE, what are the major bottlenecks for deploying EVS?
Yeah, that's a great question. So apart from support by mobiles and non-uniform coverage, what are the major? Well, right. So they're really, of course, introducing a new codec takes time within the networks. You got to make sure you've done your planning on the link side of the equation. You've got your business cases set. And then really it's a matter of choosing your approaches of deploying EVS within your networks. And GenBand has a number of solutions and tools that we can help you out with that. But there is really, I think widespread availability on smartphones is kind of, I would say, and it's a matter of time because we've already, in fact, we're aware that some of the models of the iPhone with certain modems have EVS capabilities that have not been turned on yet by the operators. So clearly the smartphones are going to have EVS given all the benefits and advantages that you just heard about, right? So really, there's no major impediments other than going through the rigorous process of introducing any new codec in your network, and GenBand has the tools to be able to help you with some of that. So I hope I answered that question.
Perfect. And another question more in terms of market and industry, right? So how has EVS gained traction from our perspective?
Yeah, so we touched on this earlier in the presentation. Clearly, we have engaged with a number of service providers and mobile operators, of course, and we're seeing a tremendous level of engagement and interest because I think everyone's looking at this. Certainly, T-Mobile US and NTT Docomo and Vodafone Germany, are some of the early adapters. They quickly saw the advantages that EVS can provide. And I urge everyone to go look at the T-Mobile US blog that is out on the internet. It really highlights well the value proposition behind EVS. Some of the things I touched on as well. But please feel free to do that, and they'll give you some more validation. But certainly, it's early days for EVS, and we're expecting more and more service providers to begin deploying these as we move forward. And they're certainly looking at NFV-based approaches to do so.
All right, thanks, Prasanna, for those questions. Again, if you did happen to ask a question that didn't get answered today, we will be following up with everyone shortly. For those of you that attended, we're going to provide you with a link to watch the recording if you wanted to watch it again on demand. Sanjay, is there anything you'd like to add to wrap up before we close out the webinar today?
No, yeah, as Lance, you highlighted, feel free to download the piece of collateral that provide you more information, and come see us at Mobile World Congress if you're going to be there. We'd love to engage with you and talk to you about this. I know there's a lot of moving parts here in terms of introduction of EVS in any given network, and it does take diligence and time and effort and homework, and we are willing to work with you on doing so. So we'd love to meet you. So come see us. We'll have additional experts from our product teams out there as well, and we'd love to engage with you. So please stop by.
Great, thanks, Sanjay. And yes, that link at the bottom of your screen there, if you click that, there should also be a button to request a meeting. So if you are going to be in Barcelona, please click that button and let us know. We'd love to talk to you. So again, thanks everyone for your time today. Thank you to Greg and Sanjay for your time as well. We appreciate all the poll answers, so thank you for your feedback. And I look for a follow-up email from us soon with a link to the replay. And we thank you all for your time. Take care. Have a great day.
Bye.